Okay, here we have 2011 scoring guidelines for question number 2. Based on what this looks like, since we have a table, we know it's a Riemann sum question, okay? We did go over this problem, but I'll go over it one more time. So here we go, part A. Notice how they ask you to approximate the rate, okay? We're trying to approximate a rate at one particular moment. That's also known as a derivative, an instantaneous rate of change. Now, we have to approximate it because we don't have the function explicitly, but we do have the table. So remember that this is pretty much your easy 1 or 2 pointer, depending on the problem. But you want to pick 2 points that are closest to this 3.5 value here. So in this case, we would use 2,60 and 5,52. Now, the scoring guidelines, they'll write the derivative as the approximation of. You really don't have to do that. Remember, less is better. If you end up writing more but inaccurately, you actually do have a chance of losing your point, so just keep that in mind. What I would personally do is, given that we have 2,60 and 5,52, I would basically just set it up and leave it, even if this is a calculator portion. So just keep that in mind, okay? So you could either do 52 minus 60 all over 5 minus 2, or both flipped, 60 minus 52 over 5 minus 2. Okay, equal is equal. Notice in the scoring guidelines, they went all the way through. It really doesn't matter. Here, they provided the actual units. Notice how nowhere in the problem does it ask you to provide a unit of measure, so we really don't need that part there, okay? So at the very least, for these Riemann sum questions, this is the very easy 1-pointer that you have to get, okay? And keep in mind that we're shooting for a minimum of about 3 or 4 points, okay? Here we go, part B. So here we want to use correct units to explain the meaning of this 1 over 10 integral of h of t. But we'll come back to that. They're asking us to use a trapezoidal sum to estimate the average. We know it's an average because there's the 1/10 in the front. Okay? So basically, the way that they have this set up here, you're more than welcome to do so. Again, there's no need to write that first part. Again, if you write it incorrectly, there's a chance that you could lose the point, okay? Now here, what's really happening is we have the 1/10 to indicate the average, okay? And the rest is really just your trapezoidal sum. Now, the way that they wrote it is a little bit different. We normally write it as 1/2 times the height times the sum of the 2 bases. So in this case, the height is going to be the horizontal distance between the first 2 points. So if you notice, the first 2 points have a horizontal distance of 2, okay? So we would put 2 in here, and then we would add the 2 bases, which is basically the 2 y values. In this case, it's h of t. We would add those up, 66 plus 60. Now, notice in the scoring guideline, they just added the 2 bases and then divided it by 2. The divide by 2 is really just the 1/2. So however you guys are more comfortable with this here, okay? I'll leave it up to you guys. And the rest is pretty much self-explanatory. The next one, 1/2, the horizontal distance between 2 and 5 would be 3. So I would put 3 in here, times the sum of the 2 bases, which in this case is 60 plus 52. And then you keep going, okay? I'm not going to keep writing everything out. Please don't put ... on your paper, okay? You want to focus on finishing it all the way through. But the moment you set it up, again, please leave it. Regardless if this is a calculator or non-calculator portion, I encourage you guys to just stop there. The scoring guideline goes all the way to 52.95. But remember, if you set it up and you stop, you automatically get 2 points there, okay? In regards to the meaning, you guys have to know that that 1/10 indicates an average, okay? H of t, if you read the problem, you know that it represents the temperature of the T. So to get that third point, the meaning of the expression, you're looking for the average temperature of the tea, but notice how they have units, okay? In degrees Celsius over the course of 10 minutes. So units are important. You can't just say it's the average temperature of the tea over time. You would have to say the average temperature of the tea with some indication of degrees Celsius, with some indication of the amount of time that you're using. In this case, it's 10 minutes, okay? Cool. Part C, here we go. Part C, evaluate h prime of t from 0 to 10. So remember that when you integrate a derivative, this is the fundamental theorem of calculus. When you integrate a derivative, you just get your function, okay? That is the reason why you plug in your upper minus your lower afterwards here, okay? Your upper minus your lower. So what we're going to do here is we need to know what h of 10 is. If you look at the table, h of 10 is already given. H of 10 is 43, and h of 0 is actually 66. So 43 minus 66 gives us negative 23. If you guys ever have issues with context, okay, it's important to look at what you're dealing with here. Notice how they're asking you to use correct units to explain the meaning of this. So just ask yourself, like, what does 43 and 66 mean? If you look at the table, it represents degrees Celsius, which is a form of temperature, in this case of the tea. So when you're subtracting 43 and 66, you're just finding the change in temperature over the course of 10 minutes. So in this case, since it's negative, we know that the temperature of the tea drops 23 degrees Celsius from t equals 0 to t equals 10 minutes. Or you could just say from over the course of 10 minutes. You could even say, instead of drops, you could say decreases by 23 degrees Celsius. But the important part is units, okay? Here's the last one, part D. They introduce a whole new object, biscuits here, okay? Initially, biscuits started off with a temperature of 100 degrees, then it was removed. So naturally, if you were to just set a biscuit aside, this temperature will decrease, okay? They give you this brand new function, which models the rate at which the temperature is changing. Again, we know it's a rate because there's that little derivative symbol right there. So a couple of things in place here. It says, using the given models at time t equals 10, how much cooler are the biscuits than the tea? So what you have to ask yourself is, what do I know and what do I not know? We already know, based on the table, that at t equals 10, we know the temperature of the tea is already 43 degrees. So the only way we're going to find out how much cooler the biscuits are from the tea is if we know what the temperature of the biscuit is at t equals 10. So what you have to do is you have to set up an integral. We're going to go from 0 because we're given that at t equals 0, the biscuit is at 100 degrees. So you always start your integral with where you're given, okay? And we're going to go all the way up to where we're interested in. In this case, it's 10, okay? We want to integrate b prime of t to see how much has accumulated, okay? But we have to consider what the temperature of that biscuit was at the very beginning, which is why we add in the initial temperature, okay? So if you plug and chug this one here, you should get 34.182-ish. So that represents the temperature of the biscuit at t equals 10. So all you have to do now is really just subtract the two values to see what the difference is in the temperature, okay? Now I'm double checking. I want to see if they mentioned anything about units. In this case, they didn't. So really, we're just looking for 8.817. There's really no need to conclude this here, okay? There you have it. Thank you.